Hello, and welcome along to our continued exploration of R and RStudio. Today, we're going to be looking at how to write a simple script in R. Last time, if you did see the last video, we worked together in the console, which is where the command line interface is. But today, we're going to learn how to write a script or a program in R, which is just a collection of instructions that we can then save and use later ourselves or share with other people. The editing of a script or the construction of a script happens in the source editor, or the script window as it's often called, and that's in the upper left-hand corner where you can see the flashing cursor. Now right now you also see that this particular script has a name. I've called it intro script R, and you may notice that it's got a .r extension. R programs have an .r extension, and that will generate automatically when you save this program. When you first open up R, this will be an untitled .r program, but then you can just go ahead and save it or open it just like you would any other file that you would do in Windows. As is good programming practice, I like to begin all of my programs with a few comments. So the comment code for R is just an asterisk, or not an asterisk, a number sign or a hashtag. We'll just give it a name. In this case, I'll call it intro script in R. It doesn't have to be this fancy, of course, and I usually like to give it a name or identify who it was who wrote it. And of course, this would be a good place to put any other identifying information that you want to have. Something that may be helpful for future people, maybe when it was written, maybe a brief description of what it does. Now, the first thing that I like to do in every R program that I create is clear out anything that's sort of resident or any objects that are sort of in memory already. As you can see over in the plot window, I've got a scatter plot. Down in the console, down here, I have some code that I've been running that's already there. So I like to clear that all out. Up in the environment window, you will notice that I have two objects, X and Y, and so on. So before I run any program, I consider it best practice to just clear all that out so I'm working with a fresh screen, so to speak. So the first thing, let's get rid of everything that's in the plot window here. So this little scatter plot that I've got. Let's go ahead and do that. So clear all plots. You're only seeing one here, but there could be many, many ones. And the code, and I'm not going to go into detail on how the coding the syntax of this or exactly what it's doing, mainly because it really does start to get a little bit technical. This is the sort of code that you should be able to use once and just reuse in every other program that you run. So there we have the one line. Feel free to pause and copy that down. Perhaps I'll put this into the description of the video as well. Now to run a script, there's a number of things we can do. You can notice that there's a window up here that we could click to run. We can run it with shortcuts as well, but I'm just going to highlight it and it will only run what's highlighted. So I'll run everything from the beginning. And what you'll notice is down in the console, you'll see that it's run the deleting of the script, and you also notice that the plots are all gone. I also like to get rid of anything that's in the global environment, any variables, any objects that I've created that are still lingering. So let's go ahead and do that now. And we'll just say clear this is what's called the workspace in R, or the overall environment. This is a lot easier. RM stands for remove. And you'll notice RStudio will automatically add in those brackets for you, those closing brackets, to make sure they always match. So this clears the workspace. It's just remove, and the list, it's just a generic list. And you'll notice now the environment is empty and we have nothing resident in memory. I often am using very, very large data sets, and so it's pretty important for me to clear out that workspace. It really can slow down the running of everything if I don't do that before I run a program, or if I'm running several in a row. And the final thing that we want to do, you'll notice here down in the console, there's a lot of things that we've run and that are already there. So let's go ahead and clear the console. And to do this, we'll just cat :\014. And this will clear the console. And you'll notice now the console below is completely empty. All of those other commands that we've run are all gone. So you'll notice already when we've been running in an R program like this, that plots show up in the lower right and output shows up in the console. And I'm just going to call this whole section preliminary setup. Maybe that's what we'll call it. One other thing that I tend to do within R is to set up my working directory. Now, working directories are really helpful. Later on, I'll show you how to read in files and how to manipulate them and deal with them. But it's helpful to have a working directory. The working directory is basically the default source that R will go to. So if you call a file, if you want to reach out to something else, you don't have to type in the same path every single time. You can just make sure that it's in the working directory. You can set the working directory, and then your code will run just fine there. That's particularly helpful if you are collaborating with other people. They just need to change the working directory in your code, and it should run fine in theirs. So to do that, we just set WD for working directory. And then we open, and you need to put it in quotations. And in this case, C:. Now you'll notice that it's a /. If you just cut and paste from your laptop, say, you'll end up with backward slashes. So you'll just need to go in and change those to /. So here we have, I'm setting the password to users math.dad data. We can go ahead and run that. And we can always double check to see if it's changed it properly just with a simple little command. And the command is as simple as this. Just get WD, open bracket, close bracket. And if we go ahead and run this, we'll see it gives me exactly what the working directory is. If I'd given it a non-user or a non-valid pass or path, let's do that and run it, I would get an error and it wouldn't change it at all. But it will tell me it hasn't changed it. So let's go back to this. Now I'll pause here and say that the working directory is a really handy thing. I've specified a local drive here, but I could easily specify a shared drive. I could put a URL in there if I'm storing things online. There's no particular limits to any sort of path or wherever it can point. Essentially, setting the working directory is just telling it to point to wherever you're storing your data or anything else that you might want to access. Okay, let's continue on then. And let's start writing our program. And in this case, this is just a program to assign vectors. I'm just going to say assign and manipulate vectors. So let's just go ahead with a couple. Let's just assign one vector. We'll call it x. Gets. You may remember the gets statement. And then C for combines. And we'll just put in a sequence of numbers, which may be familiar to some of you. And I want to have another vector as well. In addition to x, I want to have a vector, we'll call it y. And I want it to be identical to x. So I could type in all exactly the same things, or I could just have y gets x. This will give me two vectors, 1 by 10, with this sequence of numbers. So if I go ahead and I run that, we see that that's exactly what's happened. Now if I want to print these out and just have a look at them, I can just press X and run it, and it will default print it out. I don't need to use a print command or anything like that. Well, if I wanted to multiply them together, say I wanted to multiply these two vectors together, x times y, you'll see that what I've done is that 1 times 1 is 1, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 5 squared is 25, and so on. If I wanted to do something else, if I wanted to sum all of those, I introduced the idea of functions, and you can nest these ideas. I could add those all up. I could do that in 2 steps, or I could do it in 1 step as here. Now, in assigning variables, if we wanted to do a sequence, and it's a very natural sequence, we may not want to type it all out by hand. In my case, there's only 10, so it's easy enough and doesn't take very long. But if I had hundreds of numbers, I would want to do it in a somewhat more efficient way. And so we can use a shortcut. Let's create another variable. We'll say z gets combine, and I will type in. Now, automatically, it will give me a sequence of integers. Say I wanted the sequence of integers starting at 4 and going to 20, say. So we'll go ahead and run that, and we'll print that out. And there you go. You see I have a sequence of numbers 4 to 20. Now, you might be thinking to yourself, well, I don't want a sequence that is just the integers, the positive integers from 4 to 20. I want them spaced by 0.5. Well, that would be no problem. We could do the same thing. We would just change our code to get your sequence of numbers, 4 to 20, and just divide it by 2. And that will now give you a sequence of numbers, which is from 2 to 10, but going by 0.5. And of course, any other arithmetic manipulations that you want. So using this core functionality and then applying any number of transformations to it can give you almost any sequence that you would want. Well, let's make this a little bit longer. And let's say start it at 512 and go to 610. Maybe multiply it by 3. So that's going to be quite long. And here's our output from that. So as you can see, it's given us 512 times 3, which is 1,536, 513 times 3, which is 1,539, and so on. A couple of things I want to pause and point out here. First of all, you'll notice that on the left-hand column, you've got square bracket 1, square bracket 14, square bracket 27, and so on. This just tells you what element of the vector you're looking at. So in this case, in the first row, we see this starts with element 1. So meaning this is the first element in the vector. In the next row, we see 14 meaning that this is the 14th element in the vector, and so on. And it's easy enough to demonstrate just by counting these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 in the first row. Now, now this makes it very easy when you're printing out information to sort of locate a particular element if you're looking for it, or if you're looking through data to figure out, hey, which is that particular element that I'm looking at? Now, you might be wondering how many elements there are in a vector. There are a few ways you could do this. If you look under the environment, it tells you Z is numeric, and the square bracket is 1 to 99, meaning there are 99 elements, and it's a numeric vector. Or perhaps you wanted to know exactly what the length was, and you could do that because you wanted to use that number in code. You can just use the length command, and we'll say the length of Z, and it will count them all up and let you know how many elements are in that vector. And in this case, we see there's 99 elements in that vector. Another quick thing that I perhaps will show you, and we've looked at this in the past, is how to do a comparison. And we can do a comparison. We can do a comparison in a number of different ways, but in this case, we're just going to try to determine if two values are equal. And in this case, we want to see if the length of x is the same as double equals to the length of z. Now we might want to do this because from time to time when we're calculating things, it's very important that our vectors be the same length. And if they're not, we aren't able to execute the manipulations that we want to. So if we go ahead and we run this, we see that it returns false, that it is not equal. But if we were to just change it and say, is the length of x equal to the length of y? And we know it is, we know it's 10. And we see that it's true. Well, I'm going to go ahead and save this. You'll notice that intro script R now has an asterisk beside it and it's in red. That's because it's unsaved. So I'll just go ahead and save it. And now it goes back to black. And I've saved all of those changes. Well, we'll wrap it up there for today. I hope this has been helpful. Thanks, as always, for your kind attention and for following along. If this has been helpful, feel free to subscribe, and I will be posting these, and I will continue to post these as we continue to explore our RStudio and how to use those to achieve the results that we want. Thanks, have a terrific day, and hopefully I'll see you in our next video.